Hi, Math One, Mr. Bruns here again. If you haven't watched my introductory video on graphing and just what graphing is, what it means, please make sure you go watch that because that's going to be important for you to fully understand what's happening here. Today we're going to talk about graphing systems of inequalities. Now, first, what I have up here is actually a system of equations, just to remind ourselves what this looks like graphically, and then I'll quickly go through on how we solve it algebraically, although we're not going to care about solving things algebraically at the moment, okay? But just to remind ourselves, right now I've got a couple of different equations. I got y equals 4x minus 6. I've got y equals negative x plus 4. I know that those are written in slope-intercept form, and so I can look at that first one and see I have a y-intercept of negative 6, and I have a slope of 4, so I go up 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1, and then I'm going to use a straight edge here. This is an equation, and so I draw that line. There's my first line, and then my second line, y equals negative x plus 4, has a y-intercept of 4 and a slope of negative 1. So I go down 1 over 1, down 1 over 1, and again, use straight edge here to draw that line. And the solution to a system of equations was the one point that made both of those equations true. Okay, remember back in my introduction to graphing video, when you graphed any line, so if I just graph this line, I am showing every point that makes this equation a true statement. Okay, and every point that makes that a true statement is found on this line right here, that 4x minus 6 line. So when I have a system, I'm asking, are there any points? Maybe there's 0, maybe there's 1, maybe there's 2 or 5 or an infinite number. Are there any points that make both of these true at the same time? And graphically, we can see that there is. It's right here. It's that one point that is on both lines. In this case, it looks like it's the point 2, 2. Now, we learned ways of solving this algebraically, and one of those ways was to use equal values method. And so if we say, hey, they're both equal to y, let's make 4x minus 6 equal to negative x plus 4. We're just solving that system. My first step might be, let's add x to both sides. So I have 5x minus 6 equals 4. I can add 6 to both sides. I got 5x equals 10, and divide by 5, and I find that x is equal to 2. So that was the x coordinate. And then it was a matter of, let's just substitute that into either one of my equations. So if I plug that in here, I get y equals negative 2 plus 4. And sure enough, y is equal to 2. If I would have plugged it in here, I would have also gotten y equals 2. And so I find the solution is the point 2, 2. That's the point that makes both of these equations true. When x is 2 and y is 2, you get true statements for both. Okay? And it's just a coincidence in this case that your x value and y value happen to be the same thing. All right? Okay. So again, finding whichever point, in this case, there's only one point that made both of those equations true. All right. So here's where we're going with this. We are graphing systems of two variable inequalities. Okay? That's what we're trying to accomplish here. And so now notice we have to kind of use what we learned last week. We're not going to work on solving these algebraically. It's going to be all just kind of from a graphing perspective. And I have these two different inequalities. And y is greater than or equal to 2x minus 3, and y is greater than negative 1/2 x plus 4. So I'm going to graph both of those. Okay, so here comes y is greater than or equal to 2x minus 3. Remember, I just think about y equals 2x minus 3. So that is just a line. Got a y-intercept of negative 3, and it has a slope of 2. So up 2 over 1, up 2 over 1. And I'm just using these 10 by 10 grids that I found online, and I just put them into a Word document and I printed them off. So I had some nice graphs that I can accurately put these lines on. So this is a greater than or equal to, so that means that I want to use a solid line when I represent this. Here comes my solid line. Y equals 2x minus 3. And remember, we were then going to, because it's an inequality, there's not just these points that make this true, but we're going to shade on one side of the line or the other. And so we tested a couple of points. The points that we tested were, let's say, 0, 0. That's clearly on this side of the line. Or I can find some point that is on this side over here. So maybe I test, let's see, it looks like the point 3, negative 2 is on the other side. There's the point 3, negative 2. So if I try 0, 0 into that inequality, I get 0 is greater than or equal to 0 minus 3 is 0 greater than or equal to negative 3. Is that true or false? That is true. All right, great. So that one worked. 0, 0 worked. Let's just try 3, negative 2. So I put a negative 2 in for y is greater than or equal to 3 times 2 is 6 minus 3 is negative 2 greater than or equal to 3. No, it's not. So that's false. So I don't shade on the side that had 3, negative 2. I am going to shade on the side that had 0, 0. So that's this side over here, and I'm going to shade all of that somewhat lightly with green. Okay? So now I'm looking at the line y equals negative 1/2 x plus 1. That is like my boundary line here. So I have a y-intercept of 1 and a slope of negative 1/2. So I go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. And I am going to use a dashed line or a dotted line because this is strictly greater than, not greater than or equal to. So dashed line along here or a dotted line, either one works, to indicate that we're not actually including the line itself, right? So once again, I need to figure out which side of this blue line do I want to shade, okay? And again, that point 0, 0 is clearly on the bottom side or the left side of that line. I'm going to test 0, 0 because that's really easy to test. And then maybe I can test the point, I don't know, 2, 4. You can see that. 2, 4 is up here. That is above that blue line. I'm going to try that point as well. All right, so 0, 0, when I plug that in, I get 0 is greater than 0 plus 1. Is 0 greater than 1? No, that's false. Not true. I'm going to plug in 2, 4. So 4 is greater than negative 1/2 times 2 plus 1. 4 is greater than, let's see, negative 1/2 times 2 is a negative 1 plus 1. That's 0. Is 4 greater than 0? Yep, that's true. So I'm going to find the side that had the point 2, 4. That's that right there. And I'm going to shade all of that in purple. So anything above that dotted line got shaded in with purple. And so now, what we're doing, we're shading any of these points that's in the purple makes this inequality true. Any of the points in the green shaded region will make this inequality true. And I want the points that will make both inequalities true. So I'm now looking at this region to try to figure out where did I shade both purple and green at the same time. And what we find is it's all this stuff up here. That this is a boundary line right here, this solid boundary line, along with this dashed boundary line up here. And I'm going to shade in all of this stuff with red because that had the purple and the green. What we're saying is that if you name any point in that red region, that will make both of these inequalities true. If I pick the point 0, 8, that should make both of those true. If I pick the point negative 4, 10, that should make both of those true. If I pick the point 2, 3, that's right there, that should make both of those inequalities true. If I pick 6, 1, that will make one of the inequalities true, but not the other one. Same idea over here. If I pick negative 5, negative 2, that'll make one of them true, but not the other. Anything down here, let's see, 4, negative 6, that's not going to make either of those inequalities true. So that's what we're doing. We're trying to highlight on my graph which points will actually work for both of those inequalities. So there's your quick introduction. Check out the next video, and I will go through 2 more examples, and you're definitely going to want to see those 2 additional examples, okay?